number system. Look at these objects. How many trees are there? Yes, there are 5 trees. Look at these objects. How many houses are there? Yes, there are 8 houses. Look at these objects. How many apples are there? Yes, there are 9 apples. How can you say that? By counting the objects. Now these 5, 8, 9 are called numbers. That is, number is a word which denotes the number of objects, and numeral is a symbol for the number. And in decimal system, 10 digits are there for writing the numbers, and they are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0. See here, what is he doing? He is counting the number of sticks. How is he counting? By taking one by one. Look at here. What is he doing? He is also counting the number of sticks. And how is he doing? By grouping them into tens. Now, for whom it is easy to count the sticks? Obviously, the person who is grouping them into tens. For his, it is easy to count the number of sticks. And we observe that in a bank, the cashier counts the currency notes by grouping them into bundle of hundreds. It is difficult to count the large numbers taking one by one. So we group them into tens. 10 such tens is called 100. 10 such hundreds is called 1000. 10 such thousands is called 10,000, and so on. By using this idea, we can write any large number by grouping them into tens, hundreds, thousands, 10,000s, 100,000s or lakhs, and so on. See here, this is 1. See here, now this is 10. 10 into 10, that is 10 tens. It is 100. 10 into 100, it is 1000. Now 10 into 1000, that is 10 thousands. Now 10 into 10,000, that is 100,000s or lakhs. See here we consider this as 1 unit. If it is multiplied by 10, it becomes 10 units or 10. If it is multiplied by 10, then it becomes 10 tens or 100. If it is multiplied by 10, it becomes 10 hundreds or 1000. If it is multiplied by 10, it becomes 10 thousands, and so on. Now suppose if we move from left to right, then what happens? That is, 10,000 is divided by 10, then it becomes 1000. If 1000 is divided by 10, it becomes 100. And if 100 is divided by 10, it becomes 10. And if 10 is divided by 10, it becomes 1. See here the number 1 is in 1's place, and all the zeros are on the left side of the number 1. So its value is nothing but 1. Now there is no value for zeros on the left side of the digit 1. Now if we see here, 1 is in 10's place. That is, on the right side of 1, there is 1 0, and there are some number of zeros on the left side of 1. But there is no value for the zeros on the left side of the digit, and the right side of the 1 is 1 0. Therefore, its value is 10. Now if we see here 1 is in hundreds place. Its value is 100. Now if we see here, 1 is in thousands place. So its value is 1000. Here 1 is in 10,000s place. So its value is 10,000. Here 1 is in lakhs place. So its value is 1 lakh. Here 1 is in 10 lakhs place. So its value is 10 lakhs. Here 1 is in crores place. So its value is 1 crore. Now like this we can write any number. For example, consider a 4-digit number 2436. If we observe this number, here the number 6 is in 1's place. Therefore, its value is 6 into 1, that is equal to 6. Here the number 3 is in 10's place. So its value is 3 into 10, that is equal to 30. Here 4 is in hundreds place. So its value is 4 into 100, that is 400. Here the number 2 is in thousands place. So its value is 2 into 1000, that is equal to 2000. That is, the given number 2436 can be written as 2000 plus 400 plus 30 plus 6. And it can be read as 2436. Now take another example. Take a 5-digit number. Consider a 5-digit number 35684. Now what is this? This is 4. Now what is this? This is 8. What is this? This is 6. What is this? This is 5. What is this? This is 3. Now these are called the face values of the numbers. That is, the face value of a digit is the number of objects that it always shows. And the face value of a digit never changes. That means that if we consider this number 6, here the number 6 is in hundreds place, its value is 6 into 100, that is 600. But the face value of the 6 is 6 only, wherever the place may be. Now what is the value of this 4? Since it is in 1's place, therefore its value is 4 into 1, that is equal to 4. Now what is the value of 8? Here 8 is in 10's place, therefore its value is 8 into 10, that is equal to 80. Now what is the value of 6? Here 6 is in hundreds place, so its value is 6 into 100, that is 600. Now what is the value of 5? Here 5 is in thousands place, so its value is 5 into 1000, that is equal to 5000. Now what is its value? Here 3 is in 10,000's place, so its value is 3 into 10,000, that is equal to 30,000. That is, the place value of a digit depends on the place it occupies in a number. But wherever the place may be, the face value of the digit never changes. Estimating and comparing numbers. Take an example. Identify the greatest and smallest numbers from these two numbers. Now we can identify them easily by simply counting the digits in the numbers. Now if we see these two numbers, the first number has 4 digits and the second number has 5 digits. That is, the number having 5 digits is greater than the number having 4 digits. Therefore we can say that 15,348 is greater than 3,847. Or we can say that 3,847 is less than 15,348. That is, here the greatest number is 15,348 and the smallest number is 3,847. Now take another example. Compare 51,432 and 43,253. Which is greater here? Since here both the numbers have same number of digits, now we can compare the digits in the 10,000s place. And if we consider the first number, the digit in 10,000s place is 5. And in the second number, the digit in 10,000s place is 4. And we know that 5 is greater than 4. Therefore, we can say that 51,432 is greater than 43,253. Now try to say which is greater, 52,457 and 53,248. If we observe these two numbers, here both the numbers has same number of digits, and also both the numbers has the same digit 5 in 10,000 place. So we can compare the digits in the next place, that is in thousands place. Now what is the digit in thousands place? The digit in thousands place is 2 in the first number and 3 in the second number. And as we know that 2 is less than 3, now we can say that 53,248 is greater than 52,457. So here the greatest number is 53,248. Now suppose if the digits in the thousands place is also the same, then what will you do? We move to the hundreds place and then tens place and finally the units place. Now take an example. Which one is greater among these numbers? Now if we observe these numbers, now these three has same digits in 10,000s place and also in thousands place. So we compare the digits in the next place, that is in hundreds place. Now here this number has 5 and this number has 6 and this number has 3 in hundreds place. And as 6 is greater than 5 is greater than 3, therefore we can say that 34,638 is greater than 34,562 is greater than 34,323. So here the greatest number is 34,638. What is the smallest one digit number? Yes, it is 0. And what is the largest one digit number? Yes, it is 9. And if we add 1 to this number, then we get the smallest two digit number. That is 9 plus 1 is 10. Here 10 is the smallest two digit number. And what is the largest two digit number? Yes, it is 99. And if we add 1 to this number, we'll get the smallest three digit number. That is 99 plus 1 is equal to 100. So 100 is the smallest three digit number. And also what is the largest three digit number? Yes, it is 999. And if we add 1 to this number, we get the smallest four digit number. That is 999 plus 1 is equal to 1000. So 1000 is the smallest four digit number. Like that we can find any number. Now take an example. Using the digits 4, 1, 3, 7. Write the largest four digit number and the smallest four digit number. And we know that 7 is greater than 4 is greater than 3 is greater than 1. Therefore, we can say that 7431 is the greatest four digit number formed by the given digits. And also 1347 is the smallest four digit number formed by the given numbers. Next, estimation and rounding of numbers. We come across many situations in our daily life, such as nearly 30,000 people were visited Charminar in the month of April. Approximately 10 lakh students will appear for MCET this year. Now these words nearly, approximately do not show the exact number of people. In fact, 30,000 may be 29,750 or 30,125. That is, it may be a little less or more, but not exact. That is, estimation is also a good way of checking answers. We usually round off the numbers to the nearest tens, hundreds, thousands, etc. Rounding of the numbers to the nearest tens. Now consider these numbers. Suppose if we want to round off 41 to its nearest tens, then what will we do? Now here if we observe this, here 41 is nearer to 40 than 50. So 41 will be rounded off to 40. And if we want to round up the number 48 to its nearest 10, here 48 is nearer to 50 than 40. So 48 will be rounded up to 50. Now suppose if we consider 45. Now your 45 is at equal distance from 40 and 50. But by convention it is rounded off to 50. Now rounding off the numbers to nearest hundreds. Now consider these numbers. Suppose if we want to round off the number 330 and also 360 to its nearest hundreds, then what will you do? Now if we see here 330 is nearer to 300. So it is rounded off to 300. Whereas 360 is nearer to 400. So it is rounded off to 400. Then what is the rounded off number for 350? Here 350 is at equidistance from 300 and 400. But by convention it is rounded off to 400. Now take an example. Round off these numbers to its nearest tens. Now if we consider 48. 48 is nearer to 50. So we can round off this number 48 to 50. Now 62. The 62 is nearer to 60. So we can round off this number 62 to 60. Now 312. This is nearer to 310. Therefore we can round off this number 312 to 310. 199 is nearer to 200. So we can round off this number 199 to 200. Now consider another example. Round off these numbers to its nearest hundreds. Now 128. The nearest hundred for this 128 is 100. So we can round off this number 128 to 100. 275. Now 275 is nearer to 300. So 275 is rounded off to 300. 1950. The nearest 100 is 2000. So we can round off this number to 2000. 2275. The nearest number is 2300. So we can round off this number to 2300. So like this we can round off any number to its nearest tens, hundreds, thousands, etc.